Okay, you should have your peppered moth population change out in front of you, and you're going to need something to write with because we're going to be filling this in. As you go through the video, I want you to fill it in step by step, and I hope that you'll listen to this video all the way through because it's not just about filling in the right answers into these sections, it's also about understanding why we're filling it in the way that we are. And you're going to have to use this model and apply it to other species like the finches and the giraffes and the mosquito examples that we're going to do. And I won't be giving you step-by-step notes and walking you through each of those. In fact, I'll probably use one of them as an assessment to see if you understand this model for population change. So please listen to the entire video. Pause when you need to take time to copy down all of the pieces that we're going to fill in. So first we'll start with this side, which is the chain of cause and effect that happened with the moth population, and then we'll take those steps that occurred with the moths and we'll make a more general model that we can then apply to the finches, the giraffes, and the mosquitoes later on. So starting at the very beginning, when you were reading about the moths, you learned that there was a variation in the moths, that they started noticing some of the carbonaria variation appearing. And they realized that they were the same species as the speckled moths, which are now called the typica, or the typical variation of the moths. There were a bunch of events that occurred. There was the pollution, there was the change in the lichen, you read about the Clean Air Act, you read about the studies with genetics that they did, but the thing that caused this change in population, the thing that got this whole thing started, was the Industrial Revolution and the air pollution that occurred because of that change in the environment. So these two things right here, the variation within the species and the change in the environment, are the two things that got this whole chain of events started. The plus sign is up here to show that both of these events had to occur for the rest of these events to occur. So we really could put the environmental change at the top and the variation here. They can go in either order, but for the rest of the model, everything has to be in order. So anything that follows this needs to be an effect of the thing before it. So because there's variation in the moths, and because an environmental change occurred, this next thing happened. And before we fill that in, pause the video and make sure you have all the words copied down for the first two events. So the third event is the effect of the first two things happening, and that is that because there was pollution in the environment, the pollution killed the lichen, and going back to that variation, the carbonaria are now more camouflaged against trees without lichen, but typica are easier to see. Pause the video and write that down. Because the pollution kills all the lichen and the carbonaria are camouflaged and the typica are easier to see, the carbonaria moths now have an advantage because being camouflaged meant that predators ate more typica and less carbonaria. So the pollution occurred, and the pollution caused the lichen to die, and the lichen dying caused the carbonaria to be easier to see, and caused the typica to be easier to see, and the typica being easier to see meant that the predators ate more typica and less carbonaria. Pause the video and write that down. And that caused the more carbonaria moths to survive to adulthood and pass on their dark variation alleles to their offspring, while fewer typica were able to pass on their alleles because they were all being eaten. And if you are eaten, especially before you reach adulthood, you won't have an opportunity to pass on your alleles or your variations of traits. And so therefore, because fewer Typica were living to adulthood and having offspring, passing on their alleles, the proportion of Carbonaria moths increased from 1850 to 1950. So I do want you to copy down all of the things I have filled in for the moth population change. It's important that you have all of these steps filled in. It's not important that you memorize every single thing that is in each of these boxes, but it is important that you recognize that the first two things both have to occur for the rest of the events to occur. And it's important that you can see that both the variation and the change in the environment cause the next thing, which is the lichen dying, to occur, and the lichen dying causes the Carbonaria moths to have an advantage because they're not as easy for predators to see, and the Typica are easier for predators to see, and that the Typica are eaten more than the Carbonaria, so the Carbonaria have a better chance for survival, and they pass on their alleles. It's important that you can see those steps in order, because those are the kinds of steps you're going to be looking for in the other populations that we're going to look at with the finches, with the mosquitoes. And so now we're going to take each of these steps and we're going to generalize them. And we're going to try to make a statement that could be applied to any species. So we want to remove the words that are specific to the moth population, but keep the words that are describing like what is happening in that step or what is happening to the population, but remove the more specific words that just pertain to moths. So for this very first one, the variation in a trait, we're just going to say that a population of organisms varies on an inherited trait. And for the second one, that a population of organisms experience some kind of change in their environment. And that's not always going to be pollution. In this example it was. That's why we're not including pollution over here. It could have been, like we have predators way down here because that's what happened in the moth sequence. The predators didn't affect the population until after the lichen died and after the pollution occurred. But it could be, the original environmental change could be a predator entering the environment. So just keep that in mind. It's not always going to be pollution. So copy these down, pause the video, copy these down, and then you can move on to the next step. So because there's a variation in the population, and because there's a change in the environment, we're going to generalize this statement right here. This is basically just saying the change in the environment affects the organism in a particular way. So for the moths, it made the Carbonaria more camouflaged and the Typica less camouflaged. That's the effect it had on the organism. It's not always going to have to do with camouflage, but there is going to be that change in the environment is going to affect the organism in a particular way, and it's going to affect the organisms with different variations differently. And because of that, one variation is going to have an advantage for survival over the other. If there is an environmental change occurs and that occurs and one doesn't have an advantage over the other, then we're not going to see a change in the population at the end. But if there is a change in the population, it's because one had an advantage over the other because of the environmental change. And then the step that we're missing is that the organisms that have the advantageous variation live to adulthood and pass on their genes. So in the case of the moths, it was that the Carbonaria were passing on their alleles and the Typica weren't, but that could be different for each species. So we're just going to generalize that and say that the organisms with the advantageous variation are the ones that pass on their genes. And because they're passing on their genes, the final statement we're going to write is that there's a change in the population that occurs. So before you close this video, make sure that you have all of the notes copied down. I expect that you have this done by tomorrow morning, because this is what you should be working on in class today. So if you don't finish it in class, please finish it up for homework tonight.